talk in English. I will not take up the full hour, so coffee time is soon. It says in the program that the talk is on tuberculosis in orangutans. It's actually in great apes in general, because we've seen issues not only in orangutans but in chimpanzees as well. And I've stuck this up again as to link it in from the previous the talk, in that this situation is very difficult. Tuberculosis, as I'm sure you're aware, is a very difficult disease to diagnose, and that's a pain clinically anyway, but trying to explain that to people who are not clinicians is also very difficult. So getting round to getting around to managing and implementation and reviewing how you manage a situation with tuberculosis, it's nearly impossible. And what I'm going to talk about now is a situation to show how challenging it can be. So I originally titled this talk as difficulties in validating, but that was seen as too negative. So wonders of the English language, we call it challenges in validating the primitive TB, which is a blood assay that was developed for use for diagnosing tuberculosis in the cat monkeys and green monkeys. And we were able to do this in centres such as the Tasa sanctuaries that I talked about this morning, but also in orangutan centres in Indonesia. And by pairing ourselves with the AHVLA, which is the government laboratory in the UK that are reference lab for tuberculosis, we thought we might be able to do something here as well. I would also like to thank ChemBio, actually, as the manufacturer of the stat pack. They donated 2,500 stat packs for this project to see if we could if it would be worthwhile using the primitive stat pack in great apes. And various different sanctuaries there, so you can see Luero was also heavily involved in this, as was Lewis, some of the cases. The question we wanted to answer was, can we improve the diagnostic accuracy of tuberculosis surveillance under field conditions? So that's sort of out in the forest, with the acknowledgement that we are data deficient on what the situation for TB is, but we do know that the way TB is currently tested for is insufficient. In people, TB is an emerging disease again. It wasn't so long ago that they thought that TB was beating retreat in the 1970s and 80s. And then with the rise, unfortunately, of HIV and other immunodeficiency causing conditions, TB is starting to pick up again. And in areas where great apes are found naturally, in the human population, TB is skyrocketing. And we were talking about this morning about the interaction between people and great apes. The disease transmission is very high. In rehabilitation centres, it is even higher because of the conditions that are there. To add to this, in the orangutans, we had that there was confirmed tuberculosis from culture, and here's a ZM positive saying where the arrow is pointing, from some of the population historically in the centres in Indonesia. And that was discovered around 2001, 2002, and they treated those animals for TB, and then they came up negative, and then they started to get positive cases again. So it made the picture, the diagnostic picture, extremely difficult to be able to navigate, because there was a lot of information that they thought maybe the tests weren't accurate. and they wanted to improve the way they investigated it. There's also, I know we touched briefly this morning on ecotourism, the issue of, with the people in this area, their connection with the wild primates and also with livestock in the local area. What were the risk factors of spreading tuberculosis within these populations? So this top photo here is taken at a centre in Kalimantan, which is Indonesian Borneo. It's called Manatang. And they have 625 orangutans in one centre. And they have had clinical tuberculosis confirmed on culture in the orangutans. The picture below is taken at a field site in Sumatra, and that is a wild orangutan. Those are wild tourists. And just looking at the closeness of those people, let alone the orangutan, it's a young male, that one. And these are the situations where disease transmission can readily occur, and tuberculosis is one disease that will have severe consequences if it got to populations where it currently isn't. I also mentioned reintroduction of great apes this morning. It's a very controversial topic, but if you follow the IUCN guidelines, I think reintroduction can be used as a conservation tool. What you do not want to have happen is to be releasing animals that are positive for tuberculosis into the wild, and that would be a very bad thing, obviously. As mentioned this morning, you saw this photo this morning, but the chimps there have got radio collars, and they are okay. So the radio collars work with both VHF and satellite. And so those dots, it's in the national park in Guinea, this is the photo taken in the Republic of Guinea in West Africa. The dots are those chimpanzees, and so they can follow from the office where the animals are. Would anybody like to hazard a guess why there aren't any dots in the middle of the picture? What might be stopping those chimpanzees going into the middle? There, any thoughts? So there's a gap where the released chimpanzees are not going. Other chimpanzees. There was a group of wild chimpanzees in the middle there. And these animals, the official term for this release is a reinforcement. Okay, so they were releasing rehabilitated chimpanzees into an area where there already was a chimpanzee population. Now they did all the modelling to show that if they released these animals into that area, that so long as they protected that area and reduced the poaching, along with that reinforcement, then that population of chimpanzees was secure. What do you think the consequences would have been if they'd released those animals without checking for tuberculosis or other sorts of diseases? And that's why it's so important for us to be able to rely on our diagnostics for a disease that is very tricky to accurately diagnose. So we have a series of challenges. Let's say on top here. There's currently no single test that meets all the requirements for accurate and efficient tuberculosis screening in non-human primates. The most common one used at the moment is the tuberculin skin test, and that is certainly not validated. So we have the thought of combining the widely used skin test with the ChemBio stat pack. Together, we may be able to increase the sensitivity and specificity of both tests. Now, the stat pack test validation of great apes, what we hoped, and what has already been published, will improve the accuracy of those TB testing procedures in these species. How can we confirm, however, the improvements in sensitivity and specificity? What is the best test to use in field conditions where often there's no access to refrigeration? What is available, what is doable? Very challenging. Why did we choose the stat pack? Well, firstly, we got them donated, but the test has shown very good sensitivity and specificity in a variety of monkey species, green monkeys, bears, and macaques. They are stable at room temperature, which is very important when you're working in the tropics, and they're not idiot-proof, but they're relatively easy for you to use for technicians. Now, the validation trials they did in macaques was using a variety of different tests, but the actual testing procedure was that they gave the macaques tuberculosis. So they knew which of those test animals were actually infected. They then ran the antibody, the STAT antibody test, and they could be able to see how accurate it was. You can already see there's a problem. You can't do that with a population. So it's very difficult to validate the test. If you come up with a positive STAT test, what you want to be able to say is, does that mean this animal has got tuberculosis? To validate an unvalidated test, the best way to do that is to kill the animal, take further tests, and find out if it's actually positive. So, getting back to the STAT test, it's an antibody detection test. So there's a series of antigens within the STAT test itself, and they're all specific for Mycobacterium tuberculosis complex. So you would have thought this would be a good test because it's a highly specific test. And it works extremely well in macaques. They've got both a sensitivity and a specificity in the high 90s. So that was why we were going to be using that test. It works very well in closely related species, and it's been validated in a closely related species. One of our first challenges was our study group. Because of having access to a large number of animals in these centres, we were able to have a study group of 860. Now, as I mentioned before, we have 282 chimpanzees. That's more than the entire European population of chimpanzees. We had access to 527 orangutans. That's more than the world population of orangutans outside of Indonesia. So if we were going to be able to have access to that size sample group, the law of averages, which you never believe in, we're bound to pick up some positive tests, and we'll be able to do follow-up tests to confirm whether the STAT-PAC and STIM test will be able to describe accurately tuberculosis. The next issue we have is data consistency. And here are the centres in Africa for the chimpanzees. And the way to be able to standardise the way the test is run across a wide variety of different areas is very difficult. And as I mentioned previously, some of the study orangutans were previously confirmed positive on culture and then received treatment. And any test you run after that, the results on that are going to be very difficult to interpret. Different places, by necessity, had to use different types of tuberculin. So a wide variety of places would use avian and bovine tuberculin at the top, either from the UK or from the Netherlands. Some were able to import from America the mammalian old tuberculin, which was the one below. And this was, we had to separate the groups out to avoid confounding variables. This is the young chimp from Takagama who, I'm not sure how familiar you are with the STAT-PAC, but you basically put the diluent and serum sample on one end, wait 20 minutes, and the C is for make sure the test is working properly, and the T, you don't want a blue line next to the T, that's a positive test. Also in the study design was follow-up testing that would be used if you happen to get a positive result from either skin test or the STAT-PAC. And our preferred double whammy with that was PCR and culture. Now to do PCR and culture combined, even individually, but it's very expensive. So there's other tests, acid-fast bacteria, using Zell-Nielsen staining, there's a variety of other tests that are available that are based on that test. Radiographs were widely used as a diagnosis for tuberculosis in Indonesia. But of course the problem with radiographs is, unless you take the setting in a particular way, it's very difficult to interpret tuberculosis. You might be able to see pneumonia. And there was a lot of misinformation there as well. So, I'm going to go through some of the results because they are very challenging. I'm only going to do orangutans and chimps because bonobos and gorillas, they all came up negative, and the results, the numbers that you can see there are quite small. So if I just look at chimpanzees, first of all. Out of 282 chimpanzees tested, only 3 of them came up with positive skin tests, and they were skin tests only. One of these animals was StatPack negative twice, but it was confirmed positive on culture, so it definitely had tuberculosis. We'll talk about that case in a minute. The other 2 were negative on follow-up skin test, HAPAC, PCR, culture on several occasions. So in other words, we have one animal here where the skin test has picked up a true tuberculosis, StatPack hasn't. Out of the 282 chimpanzees, there are 11 that came out StatPack positive only, okay? One of these was confirmed positive on culture. Culture, as you are aware, is a specific test. However, its sensitivity is only about 60%. So if it comes up positive, it's definitely got TB. If it comes up negative, you can't say it doesn't. So of those 11 StatPack positives, we had 1 confirmed on culture. 2 were tested positive again on repeat testing, but along with the 3 others were negative on skin testing, PCR, and culture. The remaining 7 were all negative on repeat testing with the StatPack and the skin test, culture, and acid-fast bacteria. I hope you're getting confused, because it's sort of big over. But where we have, of 282 animals tested, only 2 tested positive for both the StatPack and the skin test. Both of these animals were negative on repeat testing, PCR, and culture. So, we only had 3 confirmed culture positive animals out of 282 tested. All of these animals had severe clinical signs, so they were all clinically ill. 1 was positive on the skin test, 1 was positive on the StatPack, 1 wasn't positive on either. You can't do statistics on a sample size of 3. The confirmed case StatPack positive, the confirmed case of skin test positive StatPack negative was this animal from Cameroon. His clinical signs, he was chronically wasted, he had severe lung sounds, and he was unresponsive to antibiotic treatment. At that stage, they thought he just had pneumonia. However, he came up with a Zell-Nielsen stain positive. Tracheal wash received in the UK and was then tested for PCR and culture. DNA was extracted and the sample was positive on PCR. It was also then positive on culture for Mycobacterium tuberculosis. The sample was then spongityped, and as expected, it was the Cameroon family of Mycobacterium tuberculosis. The animal comes from Cameroon. The Cameroon America family is the most common tuberculosis strain in Cameroon in people, so it kind of made sense that he had this. The very interesting difference, though, with this case is that this strain is multi-drug resistant in people. It's once a person gets it, it's very difficult to treat successfully. However, the same bacteria, the same strain, was multi-drug sensitive in Bashu. Unfortunately, you can see from the pathology photo he died before TB treatment could be, the specific TB treatment could be initiated. So there you have a bacteria that behaves very differently in a different species. You still get severe clinical disease, but it also shows that, just from this one case, then by combining those tests, it didn't help. The orangutan situation was even more confusing in as much as the skin test is well known for causing false positives in orangutans. In the first round at one site, they tested 302 orangutans in 3 weeks. So it was a very intensive trial. 12.5% of them came up StatPack positive. almost 60% of those animals came up skin test positive. They retested at 184, so those animals that came up positive in that first round all had historically had tuberculosis. They had about 10 animals historically that were TB positive. All of these animals were clinically healthy, no clinical signs at all. Stat positive, 10.8%. Skin test positive, almost 55%. All of them were tested on culture. They all came back negative. All of them were tested on PCR. There was a question mark there because unfortunately the labs stuffed up the samples and they're having to retest them. But at this stage, it doesn't look like there are any false negatives there. And with the history of tuberculosis in the group, this made it even more difficult to interpret those results. So, by this stage, we're all fairly, what had started out as a drive to be able to diagnose tuberculosis in the field accurately was becoming a little bit of a nightmare how to interpret it. To add more suspicious evidence, the first site of testing, there was a group of orangutans that were called X-tuberculosis. These were animals that either came up positive on culture or were housed with the animals that were positive on culture. They found that there was no correlation between the positive result of the stat pack or the previous tuberculosis status. In fact, but basically what that means is the stat pack was unable to find latent tuberculosis or subclinical tuberculosis in these animals that were confirmed TB positive. So these are animals that are TB positive, are not showing any clinical signs, they're latent, so therefore these are the ones that you really want the stat pack to be able to pick up. And it couldn't. Thus, the stat pack does not contribute to identifying these latent tuberculosis animals from the general test population. If you had, remember those three chimpanzees that were culture positive, they were all sick. What we're trying to do here is find a test that will be able to accurately identify animals that are not ill, but are carrying Mycobacterium. These animals are carrying it, the test didn't find them. There was a case, of Reva, who is a Bornean orangutan that mimics Bashu, the chimpanzee, but for slightly different reasons. This animal was historically culture positive, so he had tuberculosis. He was treated twice with a triple combination, and then he was clinically ill again. Now, he had acid-fast bacteria positive, skin test positive, stat pack positive, but the PCR was negative. On necropsy, there were granulomatous lesions, and they were all culture negative. This is where you sort of flip the coin, but I'm saying this animal is tuberculosis positive, even though the culture came back negative, because it is that low sensitivity. So, even having all of these tests, they don't agree with each other in an animal that has tuberculosis. So we're still at the moment having a bit of a think about everything. This is Joe, by the way. He doesn't have tuberculosis, he's just a good thinker. Little ray of light. What we now have is a group of veterinarians who understand the issues of tuberculosis diagnostics probably better than anybody else in the world. And they have been using this information to improve their quarantine facilities. They've been able to find funds for follow-up testing. And this testing can be done in country rather than trying to ship it back to the UK, which is where the original tests were done. So, a few conclusions for field use. This international network is now better coordinated to assess future diagnostic advances. One that shows a lot of promise is a urine-based PCR that we've just got into partnership with JGI, yay, and Minnesota University. The QBC Paralens is the current test that's being used in the UK to detect human tuberculosis, and it's a fluorescent dye on sputum samples, and it's got a very good sensitivity in humans, and that's through the Liverpool School of Tropical Medicine. ChemBio run a MAPIA test, which is an antigen detection test, but that is a research tool at the moment. It is not commercially available. The quantiferon TB gold assay, which is a gamma interferon test, which traditionally for primates has been pretty rubbish, is being developed in the Republic of the Irish of South Africa, and it has shown very good results in picking up tuberculosis in lions, macaques, and buffalo. And the researchers there would next like to investigate its use in orangutans in European housed zoos. So, we are still data deficient to say how accurate the combination is at diagnosing tuberculosis in grade 8. We have a sample size that is too small. So as such, we must recommend that PCR and culture should be included in any testing regime, which is precisely what we're trying to get away from, but it's especially important for release programs. In zoos, it's a pain in the bottom. In the UK, we use the skin test for our apes. We don't bother using the chromostat pack anymore based on this result, but we will PCR and culture everything. So expensive, but the more tests you run in parallel and in series, the more accurate your results are going to be. We're currently partnering with the Research Institute of Wildlife Ecology, and that's through the European Association of Zone Wildlife Vets, the TB working group. It's through them, and they've been very helpful in providing data. So we're almost up to date on TB diagnostics. That's it for TB. I was hoping that there's no answer. It's just showing you the challenges of trying to investigate